Okay, this is the second part of your review for Unit 5. This is the calculator portion of your test. So the first question, if the average value of a continuous function on the interval 3, 7 is 8, what is the integral from 3 to 7 of 2f of x? Well, let's start with this portion. That means 1 over 7 minus 3 times the integral from 3 to 7 of f of x equals 8. So that means 1 over 4 times the integral from 3 to 7 of f of x dx is 8, which means the integral from 3 to 7 of f of x, if I multiply that 4 over, is going to be 32. And if I want double that, that's going to be 64. Okay, this next one, if the function f is defined on the closed interval of 0 to 6, let g of x equal the integral from 1 to x of f of t, and we want to know the minimum value of g between 0 and 6. So this is an extreme value problem where I need to check the endpoints and the critical points. So my first endpoint is when x equals 6. So g of 0 is going to be the integral from 1 to 0 of f of t dt, which is going to be negative the integral from 0 to 1. Okay, so I'm looking on my graph here. Here's 1. The integral from 0 to 1 is just going to be the area of this rectangle here. So that's going to be 1 times 2. So this is negative 2. When x equals 6, g of 6 is going to be the integral from 1 to 6. So that would be this area, all the way out to 6. Well, this area and that are going to cancel each other out, so that would be 0. So it's just going to be this area, which is below the x-axis, so it's negative, and it's again a rectangle, so negative 2. The last thing we want to check is our critical point, which is when g of x is 0, which means when this derivative is 0. So the derivative of this is this, so the only critical point is when x equals 3. Okay, so when x equals 3, so we want g of 3, which is going to be the integral from 1 to 3, which is going to be this area here. Which will be a positive. It's a trapezoid, so 1/2, the height is going to be 2, and then the two bases are 1 and 2. So this will end up being 3. So the minimum value is negative 2. All right, another integral function. So g is the integral defined by g of x is 1 to x of f of t dt. What is g of 7 times g prime of 7? Well, g of 7 is going to be the integral from 1 to 7. So here's 1. We have this positive area and then a little bit of negative area. So, we can count squares, we can do this. So here I've got 2.5, which would be 5 halves. There's 3, which is going to be 6 halves. This part here is going to be 1/2, 3 times 3, so 9 halves. And then we're going to subtract a half. So we're going to have 11 plus 9, which is 20, minus 1 is 19 halves. G prime of x is just f of x, so g prime of 7 is f of 7, which is going to be negative 1. So g of 7 times g prime of 7 is negative 1. times 19 halves, or negative 19 halves. The function f is continuous on the closed interval between 2 and 14, and we have specific values here. So using the 3 subintervals, we're going to approximate the integral from 2 to 14 using several different methods. So first, a right-Riemann sum. Okay, so we're just going to do our rectangles. Our first width is going to be 3. So we're going to have 3 times a right Riemann sum is going to be evaluated at the right side, so 28. Next one has a difference of 5, and we'll evaluate at 34. Next one is 4 times 36. So if you plug it into your calculator, you're going to get 398, but you can just leave it as these. Is this an overestimate or an underestimate? Well, we're going 12 to 28, 34, 36, which means we have an increasing function. And if we do a right Riemann sum on an increasing function, we've got too much area. So this is going to be an overestimate because it is increasing. Next, we're going to do a trapezoid rule. So that's going to be 1/2. The first width is still 3. And then we have the 2 heights, 12 and 28. Next one is 5. 28 plus 34. And lastly, 1/2. Our width is 4. And our 2 heights are 34 and 36. This gives us 355. Is this an overestimate or an underestimate? So here we want to look at the concavity. So we want to look at, in this chart, this is 16, this goes up 6, this goes up 2, that was 4. So if I look at the slopes, here 16/3 is about 5.3. 6 over 5 is 1.2. 2 over 4 is 1/2. Okay, so the slopes are going down, which means f prime is decreasing, which means our second derivative is negative. So it's concave down. So if we're concave down and we construct a trapezoid, that's going to be an underestimate. Okay, traffic flow is defined to be the rate at which cars pass through the intersection, measured in cars per minute. The traffic at a particular intersection is modeled by this, where f of t is measured in cars per minute and t is measured in minutes. To the nearest whole number, how many cars pass through the intersection over the time interval 0 to 15? Well, that's going to be the integral from 0 to 15 of f of t. Okay, and we're just going to use our calculator. So we put it in our calculator, make sure that you're in radians. So I just put it into y1. So now I can go alpha fn int. We're going from 0 to 15 of y1. Okay, so the nearest whole number is going to be 1, 2, 3, 5. Okay, and this is going to be cars. Okay, the average value is going to be 1 over 15 minus 0 times the integral from 0 to 15. Okay, or we can just take our last thing and divide that by 15. So it's 82.348 cars per minute is our average. The temperature of the water in a tub at time t is modeled by a strictly increasing twice differentiable function w, where w is measured in degrees Fahrenheit and t is measured in minutes. At time 0, the temperature is 55 degrees. The water is heated for 30 minutes, beginning at time equals 0. Values of w of t are given in the table. Well, use the data to evaluate the integral from 0 to 20 of w prime of t dt. Well, we take the antiderivative of w, which is going to be w evaluated at 20 minus w evaluated at 0. So from the table, that's going to be 71 minus 55, which is 16 degrees Celsius. So what does this mean? Well, just think about what these values are. This is the ending temperature. This is the beginning temperature. So the temperature of the water has increased 16 degrees from t equals 0 to t equals 20. Right, now we have an integral function. G of x is the integral from -1 to x of f of t. So g of 2 is going to be the integral from -1 to 2. So here's -1 and 2. There's a couple different ways we can do this, but I know that this area and this area are going to cancel each other out. So I really just need to find the area here, which is going to be 1/2 1 times 2, which is just going to be 1. G prime of 2, well, G prime of x is f of x, so G prime of 2 is going to be 0. The second derivative is going to be the derivative of the graph we have. So it's going to be the slope at 2, which is going to be -2. Okay, is g of -4 going to be positive or negative? Well, g of -4 is going to be the integral from -1 to -4 of f of t dt, which is going to be the opposite of the integral from -4 to -1. Okay, so it's going to be the opposite of this integral. This integral would be negative, so if I have a negative, it will be positive. Okay, at what time during the interval does g of x have the smallest value or the largest value? So what we want to do is check the endpoints and the critical points. Okay, so x equals -4. I've already established that's going to be negative times the integral from -4 to -1, which is the area of this trapezoid, which is 1/2. The height of the trapezoid is 3, and then the two bases are 2 and 3. So this is going to be 15 over 2, which is 7.5. Our other endpoint is at 3. Okay, so at 3, we're going to have this area, this area, this area, and this area. So the positive area and the negative area are equal to each other, so that's going to be 0. We have two critical points, at 0 and at 2. Okay, so the integral from -1 to 0 is going to be a -1/2 1 times 2, which is -1. And then when x is equal to 2, we already did that one up here. That gave me 1. So I have 0, 7.51, and negative 1. So my smallest, or minimum, is negative 1. Oh, at what time? Sorry, so when x equals 0. The largest is when x equals negative 4. Next part, on what interval is g of x increasing? Well, we've already established that the first derivative is f of x. So from 0 to 2, and our justification is because g prime of x, which equals f of x, is greater than 0. On what intervals is the graph concave up? Well, this concavity is going to be determined by the slopes of f. So when this graph is decreasing, which happens from 1 to 3, scratch that, we want concave up. So when this is increasing, so from negative 4 to positive 1, because g double prime of x, which equals f prime of x, is greater than 0. And then finally, points of inflection are going to be when our concavity changes, which is going to happen at x equals 1, because g double prime of x changes signs. So that is your Unit 5 review, the calculator portion.